Hello, welcome to the first video about shear force and bending moment diagrams. My name is Jesus Vasquez. Well, first we need to know what is shear and bending. Shear force occurs when two parallel forces act out of alignment with each other, and bending moments are rotational force within the beam that cause bending at any point within a beam. The bending moment is the sum of each external force multiplied by the distance that is perpendicular to the direction of the force. So, to have the shear force and bending moment diagrams, we need to calculate the reactions at the supports. Well, as you can see, we use the formulas to find the reactions, and we find that A is equal to 19.6 kilonewtons and B is equal to 11.3 kilonewtons. That B there just come from taking the sum of force in y direction, and A is the sum of force multiplied by the distance. Having the reactions, we can draw the diagrams. We should draw on some grid lines because that is going to be helpful to us. Shear force diagram is going to start off here at 11.3 kilonewtons. We're going to have to include these 3 kilonewtons pressing down, so now we have 8.3 kilonewtons. Then at this point we are going to have to include these 8 kilonewtons pressing down. Right, so we can connect those lines. The section on the shear is not going to be changing because there's nothing going on this area, so that'll be a straight line. When we move across this distributed load, it is going to be increasing the shear. Here we basically just want to include, we'll take the whole thing, so 5 meters worth of 4 kilonewtons per meter is going to be a total 20 kilonewtons pressing down by the time. Here we have 19.6 kilonewtons pressing up from the reaction force, so we end up at 0. Draw on some grid lines. The bending moment diagram we can calculate getting the area from shear force diagram. So first we have 2 meters in the base and 11.3 in the height, so getting the area it's 22.6 kilonewton meters. It's the same form for the other areas, and we need to add one by one. The line has to be diagonally. This is how it is drawn when the load is at the point. This triangle we have 0.33. Let's call this distance x basically, so we need to calculate 0.33 times 5 meters over 20. It is a tree rule, and we are going to have a parabolic shape. When the area is from a triangle, this is how it's drawn when the load is distributed. Then we are going to include the last area, and it's the other part of the triangle, so the formula need to be 5 meters minus 0.083 times negative 19.6 over 2. It will be equal to 0. Shear force diagram and bending moment diagram help us to determine the value of force and moments of a structure on the application of loads at each point.